Okay, I think still many to join. In case if this number, if it won't increase fast, I will take attendance first, then I will start a class. Whenever I call your number, please answer in WhatsApp group, DC WhatsApp group. Now your number is increased to 32. Join fast. I will wait last one more minute. Then I will start attendance. Abhishek Joshi is there. Abhishek Joshi, if you are there, put your message in WhatsApp, say yes in DC group. Abhishek, you are not there. Aditi Pawar, Aditi Pawar, Vernekar, Aishwarya Vernekar, Arun Belagavi, 19 CS 13, 19 CS 13, 15, Patil, 13 and 15, Bhavana Patil, Bhagesh, 16, 19, 20, 22, 25, 27, 28, 31, 36, 38, 40, 41, 42, 44, 45, 46, 49, 7, Still many are missing there. Many have not replied. See, this attendance I will going to take again at the end, because I want to see how many of you will going to be there for throughout the class. '61, '68, '69, '70. At the end of the class, I will take it in a random fashion. Please don't answer in a comment box. You reply in WhatsApp group. That will be authenticated reply. So don't write in a comment box. I'll call some numbers randomly. $112, $115, $123, $124. Please, only these people answer. Okay. Again, this random way of taking attendance will also be there at the end. Okay. I will call in between also. Please be there. I will not going to tell you when exactly I am going to take the second attendance. I want the answer to be in an immediate fashion. In that case, I will accept it. Okay. Otherwise, you will not be considered. Okay. Next is data rate limits. Now we have seen the different ways of transmission of, say, our data. Okay. Now our aim is to concentrate on, okay, what are the factors that are affecting the data rate? Okay. What are the factors that are affecting the data rate? Okay. Basically, data rate is connected with medium. Okay. It is connected with medium. Since we are talking about the digital communication, we are talking of sending the data in terms of bits. Okay. So naturally, we express its bandwidth in bits per second. Fine. So how many bits, say, that can be transmittable through this medium? Okay. So that we will go to examine. Okay. So naturally, every medium will go to have, say, some upper threshold, that is, say, how many bits it can handle, that will go to be specified as a bandwidth. Okay. But in reality, the number of bits that it can handle is something different. Say, for example, if the bandwidth of the medium, if it is b bits per second, for understanding reason I will take it as a capital B, b bits per second. Yes, due to certain reasons, okay, those reasons we'll discuss. The bandwidth utilization will go to be, say, b bits per second, which is, say, normally this t will be either less than or equal to b. Clear? So not this t value, most of the times it will be lesser than b. Okay. So that is the reason that throughput concept has come over here. Okay. So next basic thing is that how exactly the factors which will go to affect the data rate. See, data rate here, as I said, even though I have some bandwidth of the medium, it may not support, say, complete data to be transmitted through it. So to discuss regarding this data rate limit, first we'll say reasons. Say, the data rate depends on which all the factors, first we will see. Okay. So then we'll talk regarding, say, certain theorems which helps us to understand, okay, which are the factors that actually have effect on data rate. Okay. The first thing is bandwidth available. Okay. The first point here is the bandwidth available. So bandwidth of the medium that is available. Fine. The second factor is number of levels. Number of levels of signal. Okay, in one of the class we discussed regarding these number of levels of the signals. Okay, so how many number of levels are there in the given signal, that is also have an effect on data rate. The third thing is the quality of a signal, or otherwise in a simple word I am going to talk regarding a noise. Okay, okay, so third factor is, okay, so the noise which is present in the medium. See, this noise is also one of the major factor that will affect the data rate. Okay, so these are the three main points which will going to be discussed in this topic, say by taking help of different algorithms. Okay, so we'll start with, first we'll talk regarding some idealistic situation where we are going to talk regarding a noiseless channel. Okay, noiseless channel. Okay, so when I talk about the first issue, that which first theorem which is connected with noiseless channel, that means there is no noise in the, say, channel. So this particular theorem is proposed by Nyquist. Okay, Nyquist theorem, we call it as Nyquist theorem or Nyquist bit rate. Okay, so according to this theorem, okay, bit rate, okay, bit rate is decided by the bandwidth of the channel, yes, then number of levels of the signal, number of levels in the signal. This is what we have seen in the one of the class, okay, where L indicates the number of levels that are there in the signal, and if whole thing is getting multiplied with 2, that will be the bit rate. So you see, as the number of levels increases, the bit rate will also increase. Okay, this is also we have seen, but we have some issue with the number of levels in the signal. Okay, as I told you, as you increase the number of levels of the signals, we need so many number of power supplies to be included in our system, which will be going to make your system bulky. Apart from that, the number of levels, okay, will also be going to create a lot of complications for the receiver. Now, see, whenever you are transmitting the signal as it is, okay, so this is a hypothetical situation, it is fine, but in reality you will not going to get a channel without noise. So there will be some noise, there will be some variation in the signal. Okay, so variation in the signal strength. Again, the one more impairment, that is attenuation, will also going to have an effect on the transmission. So naturally, the actual amplitude of the signal gets changed during the transmission time. Okay, so then to detect such a changes and all, we need a sophisticated things at the receiving side, which will make your receiver more complicated, which puts more burden on the receiver. Okay, so this is what is the problem with increasing the number of levels. But since it is a hypothetical situation, we will assume that we have that type of a system, and say based on this we are talking of deciding the bit rate of the channel. We are talking regarding, say, identifying the bit rate of the channel. Okay, so these say, one thing is clear from it. So this bandwidth is fixed, but by increasing the number of levels, I can increase the data rate. Okay, so next we will talk regarding one more theorem. This theorem, I think you understood. It is very simple, where we are talking of, say, increasing the data rate, increasing the bit rate based on the number of levels. Say data rate, or sometimes I may use the term bit rate, one and the same. Okay, so, and it is also dependent on bandwidth. Normally bandwidth of the medium is going to be fixed. If you increase the bandwidth, automatically bit rate will also increase. I am not saying that bandwidth will go to be, say, all the time fixed. Say for change of bandwidth you need to change the medium. Okay, so where for a given medium the bandwidth is fixed, but whereas number of levels will vary the say bit rate. Number of levels in the signal will go to vary the bit rate. Okay, so this is regarding Nyquist theorem, which is connected with noiseless channel. Now we will talk a situation which is more towards the realistic, that is noisy channel. So the channel which includes noise, channel which has a noise. Okay, so noise basically, okay, which will going to have an effect on the say outcome. So in this case, rather than talking regarding say bit rate, I will talk regarding the channel capacity, how exactly noise will go to affect the channel capacity. Okay, so see, in the previous case I was talking regarding the bit rate. Bit rate is again also dependent on the channel capacity. So you are talking of say now channel capacity, where okay, how exactly noise will going to have a say limiting effect on channel capacity. Okay, so basically according to this theorem, okay, bandwidth, okay, into say log of 2 to 1 plus SNR, 1 plus SNR. Okay, so where he tries to include signal to noise ratio to consider the noise effect on the channel, SNR is basically talking regarding signal to noise ratio. In one of the class we have discussed regarding that. So signal to noise ratio means signal power divided by noise power. Okay, so signal to noise ratio, just it will going to tell you what is the strength of the noise. So to include the noise in the channel, he has substituted this term in the equation. So by adding this equation, by solving this equation, we will come to know the capacity of the channel. If you know what is the signal to noise ratio in the channel and what is the bandwidth of the channel, okay, so the previous case also and in this case also the bandwidth is expressed in terms of hertz. Okay, I am going to explain regarding that also. So bandwidth is going to be expressed in terms of hertz. Okay, and in the end the outcome what you are getting, it will be in bits per second. Okay, in both the cases the outcome is expressed as bits per second, whereas bandwidth is going to be expressed in terms of hertz. Okay, so basically he is going to put a limitation on the usage of the capacity of the limit. Now see, basically this equation is proposed by Shannon. Okay, so it is proposed by Shannon. Okay, so it is proposed by this equation is proposed by Shannon. Okay, so we call it as Shannon capacity. Okay, now basically he eliminated that signal to noise number of levels in the signals from this equation. So naturally what will go to put a limit on the capacity? It is signal to noise ratio. No matter if you have some signal to noise ratio, if you increase your number of levels in the signal, it will not going to help you to go beyond the capacity of the channel. So that is the reason why we are talking of considering signal to noise ratio in this equation. Okay, so this helps us to know what is the actual capacity of the channel when it comes to signal to noise when it comes to a noisy channels. Okay, basically this is for noisy channel. Okay, so noisy, normally what we get is, say in reality the usage will be of noisy channel. So basically these two theorems are the one which helps us to understand regarding say the factors, how exactly they are affecting the. Normally these are the things which are asked. Say in question paper they will ask you to say write the formula for Nyquist theorem, write the formula for Shannon's theorem. Okay, this will be asked for 2 marks, and then say along with that there will be a one question, okay, one example which is based on those theorems, normally which is based on those theorems. So this is what is the pattern in the question paper. Okay, we'll see one or two examples on both these theorems. Okay, so first I'll start with noiseless channel. Okay, so I talk of say some noiseless channel whose bandwidth, okay, is 3000 hertz, whose bandwidth is 3000 hertz. Okay, and say the number of levels in the signals are 2. Okay, number of levels in the signals are 2. Since for simplicity reason I have taken it as a 2. In case if you want to examine the things by taking a 8 also you can verify. Okay, find the bit rate of the channel. Okay, so what will be the maximum bit rate achievable with the help of these parameters we need to check. So the bit rate in this case is given by 2 into say bandwidth which is required to be substituted in terms of hertz, it is 3000, and the number of levels, that is L, so it is 2. So this becomes 1. So 2 into 3000 into 1, it is 6000 bits per second. So with the help of this type of a say signal which has 2 levels, okay, we can achieve a bit rate up to 6000 in a channel where no noise is having a say there is no noise in the channel. Okay, second case, see, I talk of by changing this L value to a 8. If I change it to L value to a 8, so this value becomes what? This becomes 3. Okay, so then you see the bit rate, it is 18,000 bits per second. Okay, it is 18,000 bits per second. So you see, by changing the level say from 2 to 8, the bit rate is increased. Okay, so this is what the Nyquist theorem says, but as I said, it is a hypothetical situation where in reality we won't get any channel without noise. The second option, okay, that is channel capacity. Okay, so we'll calculate the channel capacity with say bandwidth is equal to 3000 itself. Okay, and we'll assume that the signal to noise ratio, okay, signal to noise ratio is say 3162. This is one example which I have solved. With that we'll verify. I mean, this is signal to noise ratio. In this case, there is no question of number of levels in the signals. Whatever may be the number of levels of signals, that we will not going to take into consideration. So we'll only discuss regarding say signal to noise ratio. So if the bandwidth is 3000 and signal to noise ratio is 3162, okay. Say here I have given you S by N directly. Sometimes they mention what is the signal power, sometimes they mention what is the noise power. Okay, in that case you have to substitute both the values and you need to calculate what is signal to noise ratio. Okay, so capacity, channel capacity or simply capacity is equal to bandwidth. Bandwidth is 3000 again, which is in a hertz. Okay, normally this bandwidth will be every time it will going to be expressed in terms of hertz. Okay, so then you substitute the other value, that is log 1 plus 3162. Okay, according to my calculation this value becomes 11.62 and this is 3000. If you multiply these two things, what will be the value that you see? Okay, that is 34,860. Okay, so bits per second. This will be the channel capacity with this much of noise. Okay, channel may have a say specified value more than this, but because of the noise its capacity will going to be reduced to this. So this will be the maximum capacity that can be offered to the signals or say for a transmission purpose. You can't go beyond this because of this factor. Okay, if this factor gets reduced, if you want to increase this value, you require to reduce this value. You require to this you require to increase this value, signal to noise ratio. You require to increase the signal power. So if this value gets increased, say for example, if this term, okay, if noise is infinite, zero, noise is 0, okay, so then signal to noise ratio will going to become infinite. This value will going to become infinite. Channel capacity is infinite. Okay, so as we go, say with the higher values of signal to noise ratio, the capacity will going to be a better. Okay, so this is what is the meaning of this. Okay, so if this value, okay, if this value is bit large, very large, okay, in that case, say the bits per seconds will going to change. Okay, so this is how the Shannon theorem helps us to know the capacity of the channel. Both are related and both are talking regarding the bit rate itself. Okay, so one is say connected with how to increase the bit rate. The second one is talking regarding what will going to have a limiting factor on the channel. What are the things that are limiting the say channel capacity? Basically, he is addressing the issue of noise, which will going to have a dominance role when it comes to a data transmission. Okay, now I will discuss regarding this bandwidth. Okay, so as I said, bandwidth of the signal will going to be signal or channel. Okay, the term will going to remain same. Okay, so it will going to be given by these two things. One is FH, what is higher cutoff frequency. Okay, higher threshold frequency or higher cutoff frequency minus lower cutoff frequency. Okay, these two will tell us what is the bandwidth. So usually these frequencies are expressed in hertz. Okay, so and the bandwidth automatically has to have say the answer in hertz itself. The unit of the bandwidth is hertz. Okay, so when we talk of a channel, so its capacity will be say expressed in hertz. Most of the time this particular term we use in an analog communication. Most of the time this bandwidth which is expressed in hertz will be used in analog communication. Okay, so there the bandwidth of the channel we are talking what is the upper cutoff frequency it handles, what is the lower cutoff frequency it handles, that will go to say the bandwidth of the channel. But when it comes to the signal, normally in communication we deal with say composite signals, okay, which will going to include multiple frequency components. That what we have discussed in the last class. Okay, in the last class while discussing broadband and baseband type of a communication, we come across these terms. Okay, composite signal means I am talking of creating say some signal using multiple frequency components like this. Okay, so if I have arrangement like this, okay, so I can club these three things and I can generate some composite signal which will going to be of this type. Okay, so this is my composite signal which includes all these three frequency components. Okay, so in this case, now see, this is setting one threshold and this frequency which is larger than this will go to set the another threshold. So these two thresholds will be used as say to calculate the bandwidth of the signal. What is the highest frequency component that is present in the signal? What is the lowest frequency component that is present in the signal will gives us a bandwidth. Okay, so that is again FH minus FL. So what is the highest frequency component? That is part of the signal, and what is the lowest frequency component? That is part of the signal. These two will help us to identify the bandwidth of the signal. Now see, when it comes to the communication, this bandwidth should match with the bandwidth of the channel. Then only it will go without distortion. I mean without any say distortion, and rather than talking regarding the distortion, say it will go without any impairments at a receiving side. Its shape will not going to change. But normally again say the characteristics of this bandwidth will not going to remain same for all frequencies. That will also be one of the effect which will going to have say going to cause effect on the signal. But see, these three components, now if you are allowing these frequencies to pass through it, it requires to be passed through it provided the bandwidth of the medium should be greater than bandwidth of the signal. If the bandwidth of the medium, if it is greater than bandwidth of the signal, then there is a possibility that all these components will going to go pass through it. In case if this is smaller, if this is reverse, okay, if the bandwidth of medium is smaller compared to the bandwidth of the signal, then there is a possibility that some of say frequencies will not be allowed to go through it because of say bandwidth that is offered by the medium is going to be smaller. Okay, so what exactly the condition is? FH of the medium, bandwidth, higher frequency of the medium. Okay, FH of the medium. Okay, should be greater than say HF of the signal. Okay, so higher frequency of the signal. But when it comes to the lower frequency, okay, lower cutoff frequency, that is LFLM of a medium, should be less than FM of a signal. Okay, so that means lower also should pass, higher also should pass. Okay, so if these type of mediums are there, then all the frequency components will going to be passed through that medium freely. Okay, they will pass through the medium freely. So or otherwise, what will going to happen if these conditions are not satisfied? Some of the frequency components will going to be clipped at the beginning itself. They will be chopped. Okay, they will not even allowed to pass through it because your medium is not supporting. Okay, so in that situation, the outcome at a receiving side will go to be say distorted. Okay, I hope it is clear to you. Yes, so this is regarding the bandwidth. But when it comes to digital signal, okay, so we talk rather than talking in terms of bandwidth. Okay, rather than talking in terms of bandwidth, there we talk in terms of bits per second. Okay, so basically that will going to be a bandwidth that will going to be used as a say unit for a bandwidth there. Okay, how many bits will be allowed to pass through it? Okay, so that will go to define the bandwidth there. Okay, basically this is the one factor which we will use when it comes to measuring the capacity of the channel. Okay, in analog cases we talk of using a bandwidth. Here we talk of using a bits per second. How many bits are allowed to pass through the medium? Okay, so this will go to be used in our communication, in our future discussion. Again, naturally the question arises: is there any relationship between bits per second and a bandwidth? Yes, definitely there is some kind of a relationship between bandwidth and your bits per second. Okay, we're going to discuss that in the later part. Does the bandwidth have say any effect on the channel capacity or what? We're going to discuss those things. So how exactly we are trying to relate a bandwidth to a bits per second, that we'll see to it in the later part. Okay, there is some relationship between them. So that is the reason we can use, that is the reason why we are allowed to use that bits per second when it comes to talking regarding the capacity of the channel. Okay, next we'll talk regarding one more important say criteria, that is latency. Okay, or delay, I can say a delay. Basically what exactly the latency means. Okay, sometimes we also use the term delay, or you can also say, better you say end to end delay, Okay, now look at the term end to end delay. So I am talking regarding sending the data to the destination node. Okay, what exactly latency tells us? See, moment the file start getting transmitted from sending side, yes, till the last bit of this file which is started getting transmitted from a sending side, say till the last bit gets arrived at a receiving side. Okay, so that time will go to be measured, that time is measured, that is my end to end delay or latency, that is my end to end delay or latency, the time at which the first bit starts transmitted from a sending side, time at which the last bit gets received at a receiving side. Okay, so that difference in that, or say total time that is spent to carry out this particular task, that is your end to end delay. Okay, or the total time that is required to complete this task, that is we call it as end to end delay. Now see, I'm talking regarding the first bit that gets transmitted from the sending side and the last bit that gets received at a receiving side. Okay, which all the factors will going to contribute to this latency, that we need to see. Okay, the first thing is, I start with See, just you keep it in your mind, that figure. I'll write it here again. Okay, so that you can understand, say, what exactly the latency is. These are my intermediate devices through which my signal is traveling. Okay, so our file, which are represented in the form of a signal, will go to travel. Okay, the first thing. Okay, say first thing, I'll start with sender. So now one more thing I wanted to clarify you here. So in network, when it comes to the network, most of our communication, okay, it happens in a serial fashion. It happens in a serial fashion. So whatever the communication that is happening between sending side and the receiving side, okay, the transmission, okay, the bit transmission, that happens in a serial fashion. Okay, but when it comes to presenting it to the final application, it will be again converted back to a message and it will be presented. But the bits, when it comes to a transmission of your message, which is in terms of bits, will be done in a serial fashion. Okay, now naturally the question arises, why we are using a serial kind of a communication whenever we have an advantage of using a parallel communication. If you send multiple bits simultaneously, data transmission speed will going to be better, it will be faster. But the problem is, when it comes to a parallel transmission, most of you are already aware, you have studied that in a CO, computer organization, that skewing effect. Okay, skewing factor will come when it comes to a parallel transmission. Okay, what exactly the skew means? Okay, when you are transmitting multiple bits simultaneously through multiple, say, cables, okay, or multiple conductors, okay, so even though if you are transmitting all these bits simultaneously from sending side, there is a possibility that, say, some of these bits arrive early, some of them arrive late. Okay, some of these bits arrive early or in time, some of them arrive late. So this variation in time of arrival bits of say data which are transmitted simultaneously, that we call it as skew. This will going to have a, say, very, say, large effect when the links are larger. So that is the reason why we won't use a serial transmission when it comes to a long distance communication. Sorry, that is the reason why we use serial communication when it comes to a long distance communication. But for a shorter distance and all, we prefer to go for parallel communication. Say, take for an example of your computer. Okay, in computer, all those devices which are inside the computer, okay, I mean which all the components of your computer which are inside your computer, they communicate in a parallel fashion. They communicate in a parallel fashion. Say, when it comes to a communication with hard disk and a main memory, yes, most of you are aware. So main memory and hard disk, they communicate repeatedly, so that communication happens in a, most of the times, in a parallel fashion. Okay, most of the times it is in a parallel fashion. Okay, say, not always it is true, huh? Not always it is true. One more thing I would like to add. Sometimes my hard disk, especially when it comes to a server class machines, when you are dealing with the bigger machines, okay, so server machines which are meant for some kind of a specific task and all, so there, when you are using external hard disks, okay, nowadays there is a concept of, say, storage area network. Okay, you are separating the storage from systems. Storage will be kept separately and systems will going to access this storage. Nowadays these type of things are there in the practice. Okay, so that it will help us to utilize the storage in a better way. It helps us to utilize the storage in a better way. In this type of situations, they use serial communication again. They use serial communication. If the distance is increasing, if a distance is large, okay, then they prefer to go for serial communication rather than parallel communication. Okay, so if a distance between devices or components is smaller, then it is preferred to use parallel. So that is the reason in a standalone machines, in a standalone machine where the hard disk is part of your system, okay, so there the parallel communication is acceptable. Okay, but when it comes to a longer distance communication, serial transmission is better. Okay, so for that reason we talk of serial communication. Okay, so why all those things why I have given all this is mainly because, to start with, I will start first going to calculate the first reason for, say, or a first thing that will going to contribute to our latency, that is transmission time. Please note down these things. Please note down these formulas, okay, which are needed to solve some examples. First is transmission time. What exactly this transmission time means? Okay, as I said, it is a serial transmission. Okay, so when you are talking of transmitting some file of some size, say m bytes or m bits, okay, m bits, your file which will going to be expressed in terms of its capacity will be expressed in terms of bits. Okay, so whose capacity is m bits. Okay, to transmit this m bit file through the medium, okay, since it is a serial communication, we need some time to push this whole m bit into the medium, whole m bit into the medium. Okay, so push these m bits into the medium. Okay, so we need some time. That time depends on what? Yes, that time depends on what? It depends on the size of the file. Okay, size of the file. Okay, this is the one which will go to decide how much time is needed. Then at what rate we are pushing it inside the medium, or what rate the medium is accepting this transmitted bits. That also will go to be having going to have some effect. Okay, so that thing is, we call it as bandwidth. We call it as bandwidth of the medium. So size of the file divided by bandwidth of the medium will going to give you a transmission time. If your size is say 3 megabits, okay, 3 megabits, fine. Size of the file usually it will be expressed in megabits. Sometimes they give the size in terms of bytes. Okay, you require to convert that into a bits. Okay, then what is the bandwidth? Okay, what is the bandwidth that is offering, or what is the bandwidth of the medium? Okay, so that, say if it is say something 3000 bits per second, so this calculation will help us to get, or if by dividing this I am going to get, say, the transmission time, how much time it will going to take to push this whole file into the medium. So if the bandwidth is small, time taken will going to be large. If bandwidth is large, you can push these bits at a faster rate into the medium. Once if you push, say, once the sender pushes all the bits of the file into the medium, it requires to travel through this to reach the destination. Okay, so naturally you are converting these bits in the form of signal and you are sending it through the medium. Yes, so how much time is needed to move from this place to this place, that we need to calculate. That we call it as propagation delay. Okay, so it requires to travel through this medium. Okay, so naturally it depends on what? It depends on distance and at what speed the signal is moving through this, say, medium. Okay, so first thing is speed of signal divided by, say, speed of a signal divided by, distance divided by speed. Distance divided by speed. Okay, which will help you to find the propagation delay. What is the distance and at what speed the signal is traveling? That helps you to calculate the propagation delay. Okay, so this formula you have come across in the physics. Okay, so when it comes to calculating the time needed to travel from one point to another point, that time, say, distance divided by speed. Speed here indicates speed of a signal. Okay, so when it comes to electromagnetic signals, okay, or say the signals which are getting transmitted through this medium, so normally it will be at a speed of light. Okay, again, Say this is the idealistic situation, but it depends on the medium. So normally, whenever the propagation speed is not mentioned, propagation speed of a signal is not mentioned, in that case you have to take this as a speed 2 into 10 raised to 8 meters per second. 2 into 10 raised to 8 meters per second. Okay, so you are free to take this value, or otherwise they will mention it is traveling at a speed of light or so. So in that case, you have to take it as 3 into 10 raised to 8 meters per second. So normally the speed of a signal they won't mention. You take it as 2 into 10 raised to 8 meters per second. So this second component is propagation delay. So third thing, sorry, that figure. Third thing, yes, which is the third factor. Basically, propagation delay and transmission time, they are the main contributors for end-to-end delay. Okay, but there are other factors which will also play a certain roles. Okay, so like say whenever your signal it is made to travel through this, even though these devices are meant for some specialized task, their job is to accept data and forward it. But normally they are serving multiple such devices. Naturally, whenever a data comes from this link to this intermediate device, okay, so what happens there? They gets queued up. They gets queued up over here. Okay, so they come and dumped in the queue. Okay, because it needs to process each and every packet what it gets, or each and every message what it gets. Say you are transmitting it bit by bit, it requires to wait certain bits to be get collected. After certain bits gets collected, it requires to process that. Based on the process on which outgoing link the packet is to be sent, that it requires to decide. Okay, for that certain time is needed. So that time we call it as, okay, so that time we call it as processing delay. We call it as processing delay. We call it as processing delay. Okay. Next is that, as I said, whenever it enters this device, first it will go to be put in a queue, because these intermediate devices, they are meant to serve multiple devices or multiple such connections. Naturally, from every connection the data will go to come to them. Every data which is coming at it will go to be first required to be put in a queue, because it has to process that. So it requires some time for processing. So when it is taking some time for a processing, naturally certain data will go to be queued up. So if data gets queued up, so that delay we call it as queuing delay. Okay, queuing. Say I have written it in a short form QING. So you take it as queuing delay. Okay, so queuing delay. Okay, so processing delay, queuing delay are another two factors which will going to be added to the end-to-end delay. Okay, so I'll write now the complete formula of latency. Okay, most of you are already aware regarding this. Okay, be prepared. I am going to take attendance now. Okay, now total latency formula I will write. If you had any doubts and all, you are free to put in WhatsApp. I said I have not received any message in the group regarding your doubts. The latency, how we are going to calculate. So the complete thing, that is end-to-end delay. So first thing is your transmission time. Transmission time. Next one is propagation delay or propagation time, one and the same. So I have simply written it as PD. Yes, plus queuing delay, QD. Yes, last one is processing time, processing delay. So these are the four factors which will help you to find the latency or end-to-end delay. So one thing you keep it in mind, there will be a one question on this particular example. Most of the times they have asked, okay, some questions on finding a end-to-end delay. Okay, we'll see one example. So I think it is 10:54. Okay, so rather than discussing that example now itself, okay, so I'll discuss it in the next class. So this is what is the formula you require to remember. Okay, in the next class, while you are coming to the next class, please prepare yourself regarding this, go through it. We'll discuss one example on latency. Okay, I'll check how many of you are there. Okay, anyway, the number is good. Okay, according to my say input, it is somewhere around 59. Okay, so anyway, based on the first uh, attendance, I'll go to mark you all. Okay, another 2-3 numbers randomly I will call, so please you say yes to it. Only the called numbers you answer to my question, say reply in the WhatsApp, not all. Okay, randomly I will call 124. 124, you answer in DC group. 406, are you there? 406, 20 CS 406, 20 CS 407, 20 CS 410. Please answer yourself. Please put your message. I'm going to post the book, soft copy of the book, as soon as I get it. Okay, so the problem is all my notes are in the college machine. I have say very little document in my laptop. Okay, all the soft copies are in the college itself. Again, from today, there the restriction is bit say tougher. Okay, so we are not allowed to go out only with the vehicle. So reaching a college by walk takes a lot of time. Okay, so for that reason, what I will do is I'll try to get it from somebody and then I'll post it to you. Okay, so I'm searching for PDF, and even I have a PPTs of all these discussions. I'll go to post it to you. Okay, if you had any doubt and all, you are free to discuss. I have seen sometimes what happens, my laptop get disconnected from the Wi-Fi because I have to take this class in a closed room. Yes, so that is the reason sometimes I won't get a signal, and in that situation I won't see the message. Okay, that is the reason say I'm not instantly replying to your queries. Okay, anyway, please be in touch through WhatsApp regarding your any issues. Okay, thank you very much. You are now allowed to quit the class. Thank you. I'll go to end the stream. Anyway, most of you are answered for attendance. I have taken it randomly now, the last part. Please, you are allowed to quit. Put your USN in comment box and leave. Put your USN in comment box and leave. Four 10 is absent. Please enter your USN now in comment box. Not here. Please enter your USN in comment box and leave. Anyway, I marked, but still you put your USN in comment box.